Now this is undoubtedly the most technical part of our build, the trolley rail carriage for our trolley rails. I'm going to take you through step by step how we build this trolley carriage. And I'm going to make some suggestions to make your life a little bit easier when it comes to the drilling. All right, because it's important that we get our holes, guys, in our angle. We're using the same angle as what we've used as our rails to carry our bearings. Now, being 3mm, it's pretty thick. So, guys, it can be challenging to drill this and get a good straight drill on top of actually drilling it, okay? So I'm going to make a suggestion of something that you go out and purchase. It won't cost you a lot of money. It's not like my proper drill pedestal press, but it's something very similar. And for the DIY person, it will get you through this part of the build and just make things a lot more accurate than trying to drill these particular pieces of angle for this particular application by hand. So in typical Dr. ADHD style, I shot this entire bit of footage yesterday of putting our measurements together for our trolley carriage angle and getting this drilled. But when I went through the measurements and how to get them in with our digital calipers, I didn't realise that basically my arm was interfering with the footage the whole time. So here we go, we're shooting this again. This is what you're heading towards, guys, is our little trolley carriage for our trolley rails. We're about to build this. And we're starting with our 40 by 40 by 3mm angle here. Let's move that out of the way. And let's get this show on the road again. Now, this is a little project that you guys could take on, and it'll be a good little bit of welding practice for you, okay? And I've talked about having a vise a few times, all right? This is a good way to set a vise up on a table for various reasons, stability, etc. And it's a good way to clamp to a table if you've got nothing to actually bolt your vise into. This is a 150mm vise, portable vise that I've set up. This is an old brake rotor out of a car. These can be found at wrecking yards, etc. This is cast, okay? So is the vise. So you can get away with welding these two together and not have major issues with your weld cracking as it cools, because they're both cast. So they cool at a similar rate. If you can find yourself one of these, a brake rotor, and as I say, they're pretty easy to come by, 150mm vise, you can certainly weld your vise to a rotor, and this has a fantastic surface area to get clamps on. All right, so this could be a little practice project before you start your main project to get a vise set up, okay? It's just tacked around in different locations, and it works really, really well for applications like this one that we're about to undertake. Okay, now guys, this is a fairly technical part of the build, but in saying that, I'm going to give you some tips to help you get this stuff drilled accurately, all right? I'm going to make a recommendation for a little drill press that I would encourage you to buy. It'll cost you around $70. This one I'm showing now in the video here, you can see. This can be purchased at the electronics store here in Australia called Jcar, but you can get these online. This one at Jcar's around $70, it's $69, okay? Now this is something that's relatively cheap and gets you in the ballpark of a drill press. It's not a proper pedestal drill press, but you can get your hand drill clamped in this and it will do pretty straight drills, okay? It will give you a pretty straight drill compared to trying to drill these holes by hand, all right? We need to get these holes accurate, okay? They need to be accurate and we need them to be straight because these are carrying our bearings. Now, this, if you went out and bought that press, it will still should still sit inside the budget that I've estimated for this build, okay? Remember, any tools we're using, guys, materials, tools, etc., that you see me using that I recommend for you are all within that 2,500 AUD budget, okay, including our digital calipers. Let's talk about quickly our digital calipers. Get a set of digital calipers, guys. These can be had for $9.95 on eBay, right? But you'll buy cheap, you'll buy twice. All right, so don't cheap out too much with stuff like this. For about $30 on eBay, or in fact even at one of your hardware stores, you'll get reasonably built set of digital calipers. Now, they don't have to be digital. They can just be so then they run off your scale. That's fine. Digital will help you out a little bit more, and they can, if they're a decent set of digital calipers, they can be a little bit more accurate than trying to look by eye. So we do want accuracy for this next step, for getting our hole sorted out here for our angle and our hole sorted out for our plate. Okay, to build our trolley rail carriage, you're going to need 1 metre of M12 threaded rod. 1 metre or 1,000 millimetres of M12 threaded rod, and you will cut your rod to 240 millimetre lengths, and you will cut 8 of these in total at 240 millimetres. When you cut them, guys, use that method I've shown you with the angle grinder upside down with your sanding pad, and just round the edges where they're cut. Otherwise, you'll have a hard time getting your nuts on. You will need 32 M12 nuts and 16 M12 washers to go with your rod. You're going to need 1.2 metres of 100 by 5 mil thick flat steel. We'll be using our 40 by 40 that we've got left over, and these will be cut at 100 millimetres in length. 100 millimetres in length. You'll need a couple of boxes. This is a 25 pack of M10 washers. These are for spacing our bearings when they go on our angle. 2 packs of those, you'll have stuff left over, okay? You'll need 16 25 millimetre M10 bolts with a nut, okay? This was a pack of 25 found at Bunnings. I'll have some left over. That's all good. I'm always using nuts and bolts. Okay, here's the kicker, guys. You need to get yourself 16 precision bearings, all right? 16 sealed precision bearings. Now, this bearing is rated at 244 kilograms, okay? There's 4 of these on our little rail system, and they're all in pretty close proximity. So they're going to pack quite a lot of load for what we need, which is what we want. We are also getting some side load on this stuff as we're using our sim, so for it to be over-engineered in this case is definitely not a bad thing, all right? A sealed bearing, precision bearing, all right? Now, the specs for this bearing, this is very important. The bore, okay, is 10 millimetres. It's a 10 millimetre bore. The overall diameter of the bearing is 30 millimetres, and it is a 9 millimetre in width bearing. So for my American friends in the Imperial system, you need to be somewhere in the ballpark of those specs, converted from millimetres to inches, all right? It won't matter, guys, if the bearing's a little bit larger, okay, by a couple of millimetres, but it will matter if the bearing is smaller. You can't have a smaller bearing. It has to be this size that I've given, or it can be a couple of millimetres larger in diameter. Only a couple. The very important thing is the bore, right? Now, with this particular bearing in Australia, because it's an M10 bore, those M10 bolts that I just showed, they fit exactly snug into this bearing, so there's no slop, okay? There's no play. They're a tight, snug fit, meaning that our inner race won't wear, okay? And they need to be snug, and they need to be not have too much end play, too much slop, all right? So you've got to keep that in mind with your bearing selection in inches when you come to select these bearings if you're in the States. Pretty sure my European friends, anyone in Australia, we're all in the metric. So you'll be okay if you go with those specs. Now, let's get back to talking about how we set this up now, because like I said, guys, I shot this yesterday. All my pieces were cut to size. This is a little bit of scrap left over. It's longer than what our actual setup is. It doesn't matter. The measurements are the same. I can show you what you need to measure. We make 2 slightly different measurements on each face, okay? There's one measurement that's the same on both, and that's our distance where our holes go in from our edge, from the top of our triangle. The distance into our holes on both sides are the same, but as you can see, guys, the holes are offset. That's so then when our bearings go on and our bolts come through, or our bolt heads sit in the bottom here, they don't interfere with one another. That's why they have to be set offset. So they're the two different measurements. The distance is the same from our top of our triangle, but these are offset. So I'm going to give you the measurements now. I'm going to show you the best technique for getting these measurements. So if you've gone ahead and got your vice project, it's going to be very handy for working with angle, all right? So you'll take your digital calipers, right, and you'll turn them on, make sure they're zeroed, so make sure they're closed and they're zeroed. In my case, I'm going to use millimeters. I can select inch with these, but I'm going to use millimeters because I'm in the land of Oz. So find your 10 millimeters. There we go. Oh, yes. Guys, as long as you're 1/100th of a millimeter within what I've said, okay? 9.99, that's fine. Or if it was 10.01, that's fine. No more than that. Sometimes it can be really hard to get these to stay on the exact measurement. It depends. If you've got a really high-end set of digital calipers, they'll probably be okay. They'll be accurate. These always sort of fluctuate between 1/100th of a millimeter. That's okay. Don't stress about that. Right, so from one face. So what I do is I basically set my angle up so that I'm always working on the face that is going to be where it's 90 degrees. It's always facing away from me. Okay, so I've got lots of meat to drag back on. So I've mentioned about using our calipers. To use our calipers, guys, the best way you'll get a scribe, so you can see, guys, I just sit on the edge, on the inside part here, and then this part is the part that we scribe with. And you need to get a sharp angle for them to really dig in and actually give you a decent scribe. Mine are starting to get a little bit blunt these days, but if I do a nice sharp angle, then they will do a decent scribe. Now, I could get one of my hole shot clamps in my my table here and clamp this. I don't need to. You don't have to be violent with this. You just got to be precise, okay? It needs to be a nice, smooth scribe in, okay? It just needs to be a line that you can see, all right? So 10 millimeters for this one. Do the same on this one. Now, you'll have 4 pieces to work with, so keep it at the 10 millimeter mark and do all 4 while it's set up at this measurement, okay? So then just do all 4 one face. Once you've done all 4, okay, you need to loosen this off, take it back to the start, close it, zero it, and then you're going to find 30 millimeters. Wow, that's a rarity. Okay, 30 millimeters. And then on the opposite face, I'll just turn it around so it's, again, facing away from me on the 90. On the opposite face, we haven't marked. We're going to do exactly the same thing. And this is our offset hole for our second bearing, all right? And you'll just do the same, guys. Make sure you're getting it from the edge all the way through as far as you can, because you need to pick up the next line that we're going to put in. Okay, so hopefully you guys can see the lines on that. All right, and on that guy. So these are a 10 millimeter line, okay, and these are a 30 millimeter line. Okay, the next line we need to put in, guys, goes the distance, goes the full length. You can just see the scribe on this even after I've cleaned the mill scale off. Okay, so get this nice and clamped in so it can't move, and cock your lines up. Again, zero these out, all right, close them, zero them out. Now you're going to get a 15 millimeter mark in here, okay? 15 millimeters. Another rarity, but I'm taking it. Normally I can't get it spot on, guys. I can be honest with you. Normally I've got to have it within that 100th. So that's nice. Okay, and what we're doing, guys, is on our top of our triangle side here, this is where we're running our scribe to pick up where the distance in from the top of our 90, where our drill holes go. Okay, it's actually worked out well that I've had to do this again, because I can show you what's actually happening with this on the piece that's been already drilled. And nice and carefully, guys, I use two hands, one to just keep this stable. Now be careful, guys, you can contort this, okay? If you're too violent with these, you can definitely contort them. See this? That means that's going out, all right? So you've got to be gentle but firm, all right? So I use two hands. I use one on the scribing side, and I just hold this in nice and close. Get a really good angle, guys. The better the angle like this, the more it'll scribe, especially when they start blunting up a bit. And you need to do both sides. From the top of your triangle. Okay, now hopefully you can see this. In fact, I'll come around my camera. Yes, so you can see those lines there, guys, where they cross here. All right, where those lines intersect on both sides. That's where you will punch, where the lines intersect. That's where you'll punch, and you're going to drill these with a pilot hole first, and I recommend you pilot these with a 6mm pilot, all right, or a 5mm pilot, and then you finish with a 10mm drill bit for your M10 bolt that will hold your bearings on. Once you've got those drilled, okay, once you've got them drilled, then you need to take all the mill scale off this side, all right? On the inside section, for want of a better word, this won't see paint, this will be plated. You will just simply clean up around the bolt holes, because we'll be putting one of our bolts through. We will be welding these bolts in. They come in from the underside of our angle, all right? We'll be just giving these a couple of decent tacks to keep them in position, because this gets plated. We won't be able to access these. A washer will go on here to space our bearing out. Our bearing goes on, and our nut goes on to hold our bearing. The side our bearings on, guys, will be painted. We'll take our bearings off. So get these completely cleaned down to shiny metal. This side you don't need to, you won't see it, but clean up around your bolt holes on this side for welding. Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, and take it easy out there.